7.4 three-dimensional figures. And really this lesson's a lot about vocab and a few skills here, but it really sets us up for dealing with surface area and volume. So first, a polyhedron is a solid bounded by polygons. All right. And if we were to label faces, vertices, vertex, and edges on this polyhedron, or well, I'm going to label the edges for sure in the vertex. Vertex is every little point you see every time it comes to a corner. That's a vertex. Okay. So vertex, and there's multiple vertices on this. An edge, your edges are your lines here. Okay, that connect your vertices. So these are all edges, right? When I'm tracing here, those are all edges. Now I'm not doing an amazing job of tracing, but just trying to point out all of those are edges. Okay, so we'll label one of them here, but they're all edges. And then the remaining, these things, these what look like trapezoid, or not trapezoids, but parallelograms or rectangles, or this trapezoid in front here, those are called faces. The planes of this, those are all faces. Okay, and so just kind of pointing to the inside here, that is a face. Now, however you want to label that. Now we have special names. Oops, excuse me there. We have special names for the shapes that are not rectangles, and we call them bases. So this is a face and this is a face. However, this face right here, that we're to kind of bring, we call that a base. And it's a base because that face has a special shape to it, whereas these are just rectangles. And we're going to see that here in a minute. But first, let's go ahead and talk about types of solids here. So you have two types of polyhedra. There's a prism and a pyramid that we're going to study, at least for this lesson. The prism has a base with rectangular sides connecting it, versus a pyramid where you have all your sides, or all your faces, excuse me, come up to a single point. Okay, notice on a prism, you have two of the same bases. You have a pentagon and a pentagon, and connected by a bunch of rectangles. A pyramid just has one base, a pentagon, and jetting off that pentagon are a bunch of triangles, and they come to a single point at the top. That's a pyramid. Notice all lines are straight. Okay, all of our edges are straight there when I say our lines there. Versus not a polyhedra. Well, a cylinder is not a polyhedra. A cone is not a polyhedra. And a sphere is not a polyhedra. And you look at those, well, they all have curved surfaces. That's why they're not polyhedra. Okay? And so when I think to the types of solids, the base of a prism, okay, when I'm looking at, say, this prism right here, this prism has a base that's a trapezoid. It's the first shape we dealt with. Okay, in fact, rather than me shading it in, let me trace it. I have a trapezoid. Okay, and that trapezoid right there is congruent to this trapezoid back here. Okay, and so the base of a prism is the congruent parallel polygons connected by rectangular faces. So when I look at this and I say, okay, well, those two trapezoids are connected by this rectangular face, that one on top, that one over there on the side, and this one on the bottom. Okay? That's your lateral. Those are your lateral faces. All right. So if I'm naming this figure, we name it based upon its base. So it's a trapezoid prism. All right. Well, the base of a pyramid, like I said before, is the side. It's the polygon opposite the apex or the tip of the pyramid. So up here, that could be the base of the pyramid. Now, when it's a triangular pyramid, technically, any of those triangles could be your base. Okay. So this is a triangular pyramid. Now I just labeled this as my base, and those triangles are connecting that base to the tip. However, we could have said, well, maybe this is my base right here. And those triangles are going out to this tip. Okay? It's kind of weird when you have a triangular pyramid, or for that matter, if you have a rectangular prism, right? Rectangular prism, any of these rectangles could be the base. That could be a base, and the one opposite, and it's connected by rectangles. Or you could say, well, this is my base, this top, and then the bottom is the base, and they're connected by a bunch of rectangles. However you want to think of it, this is a rectangular prism. Okay? Well, this is a sphere. And then over here, notice this is a pyramid. It comes up to a tip, and it has a rectangular base. So this is a rectangular pyramid. You have that rectangular base right there. Okay? Now, we got ahead of ourselves. Name each figure. We did that. But is it a polyhedron? Well, yes. That's a polyhedron. So, yes. 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 They all have straight edges here. Okay. Yes. Now, notice I skipped the sphere because that one's no. We have curved edges. All right. Let's go ahead and move on. We'll talk about cross sections. All right. The intersection of a plane and a prism is called a cross section. Okay, and really what that means is you have a plane like a flat surface cutting through something. So use shading and dashed lines to show how how the cross section forms each polygon listed below each cube. A cube means all sides. That means all edges. Let's go that route. Are congruent. Okay, so it's a perfect cube here. So how could we make a square with a plane going through it? Well, let's say I had a plane that just kind of, let me actually dash in the rest of this here. Okay, when we use dashed lines, remember those are hidden lines, or hidden edges there. Okay, now if I had a plane that cut through, say the middle here, we just took and we sliced through the middle of this, or anywhere in it, in this cube, we would end up with a shape that looked like that. And that shape would have the exact same length of each of the edges there. And so that would be a square. So it would be like taking a sword or something and then just slicing through that square. And then if we were to look at where the part is that I colored, that painted part, I would have two pieces, and each of them would have that square face. Okay. Let's say we want a rectangle that's not a square, and we have to get a cross section. That means you can't just say you cut it right here and say, hey, here's a rectangle. Okay, that doesn't work. The cross section would be if I went down like that. Okay, well, that doesn't give me a square. That gives me, or that doesn't give me a rectangle. It gives me a square. So a cross section could go from, say, like here down to here. Okay, so let's say go like that. Oops, let's try that again. Okay, so I have this plane that's doing something like that. It's cutting through it. Now, because I've actually covered up some of the lines of that, kind of messes it up a bit. So let's actually draw these lines back in here, so it'll be a little easier to see. Okay, so there's your cross section, just kind of like this one should have that line drawn back in. That'd be your cross section. So it goes from edge to edge diagonally, and you now have a rectangle. This is congruent to that. That's congruent to that. Okay, whereas on this one we had all congruent. All right. So cross-section has to be along the cut, okay? So let's say I want a triangle. Now there are multiple ways of doing this, and I actually had a different picture, but one of my students today, Kat, her name, and she decided to draw this one. We had a triangle. It went from here to here, and then down to here. And I think that's a really good way of seeing it. So if I were to actually shade that triangle, like so, it's like I'm cutting off that edge, right? So I'm cutting off that corner of the triangle. And that would be the piece that I'm left with right there. So really, I've cut through and cut this piece that I just traced back on. I cut that off, and I'm left with that triangle as a cross section. Pretty cool stuff. All right. One other thing is, and by the way, there's tons of things. We could have made a trapezoid out of this if we would have moved our cut down just a little. It would have given us a trapezoid. So there are a lot of different things you can cut out of these polygons using cross sections. Okay. All right. A lot of art going in there. Let's go ahead and talk about sketching and describing solids of revolution. So a solid of revolution is a three-dimensional figure that's formed by rotating a two-dimensional shape, for instance a rectangle, around an axis. And we call that axis the axis of revolution. So here's our axis of revolution. Our job is to sketch the solid produced by rotating the rectangle around the axis. Name the solid, identify and label the dimensions. Okay, so if I start rotating this, first of all, when I rotate this, I'd rotate it around like that, and then I keep rotating, and eventually what it does, it's going to form this circular shape here. Okay, if I start spinning that. One way to do this is take a note card and tape it onto a pencil and start spinning it around. You see the rotation I'm talking about. The one way to draw it is, well, you could take this just right away and reflect the shape over that axis because it's going to rotate around it. So that shape's going to end up down here. Now I'm going to do it this way, and then I'm going to actually probably draw it another way. Okay. And then what I know is this shape rotates around the axis and then rotates back up. Oops. All right, let's try this. Okay. Not amazing, but it'll do for what we're doing here. And then we rotate around the axis. Then back up. Okay. So now you start looking at that and you're like, I can't see what type of shape that is. Your eyes have to start adjusting. So this line right here would be a line that's behind it. So it should be a bit dashed than solid. And this is why I will redraw it here in a minute. Okay. And so you kind of see a cylinder. Some of you might be able to see a cylinder. You really have to use your imagination. But what's happened here is you get a cylinder. Okay, you get a shape with two circles at your ends and connected by that rectangle there. Okay, this circle here should be dashed, at least the way I drew it. So there we got it. If we were labeling it, well, that's a cylinder. Its dimensions, well, the radius of our cylinder is 2, and the length of it is 7. And so we just take those lengths and we put them back in there. Now it doesn't have to be the same size as the one you had, but you just have to label it and title what type of shape it is. So if I look at this one over here, well, if I take this triangle and put it and rotate it around, reflect it over, I get this triangular shape. Now remember, it's spinning, right? And so we're spinning this, it's like this point just starts spinning around. right? We start spinning around. Well, notice that gives me a base of that triangle. Well, the base of that triangle, when I draw it in, actually makes it look like a cone. Okay? And so this shape is a cone. You have this circular base that rotates around the axis. I don't know what just happened to my picture there. I've had something on my screen. That's a good excuse if I didn't. Okay, there we go. And notice, once again, my base, it should be dashed back here, so we'll do that. All right, and we go from here to here. That has a length of 3, or a radius of 3, and then the height of our shape is 5. Okay, if you're struggling with any of these, just take a pencil, tape on the shape that we started with, and rotate it around. You'll start seeing, if you put a little piece of lead here, 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 you could even trace out the shape. All right, very good. Well, that's all I got for you. Good luck.